Let us do question number 2. In figure, D and E are 2 points on BC such that BD is equal to DE is equal to EC. So in our figure, D and E are 2 points on BC such that BD is equal to DE is equal to EC. And in this question, we have to show that area triangle ABD is equal to area triangle ADE is equal to area triangle AEC. So we have to show that area of triangle ABD is equal to area of triangle ADE is equal to area of triangle AEC. That means these three triangles which are formed are equal in area. And our key point here will be area of triangle is given by the formula of half base into altitude. So we have to show here that area ABD is equal to area ADE is equal to area AEC, and our construction here will be, we will construct AM perpendicular to BC. So we have to construct AM perpendicular to BC in order to prove this question here. Let us prove it. Now in our key point also we have discussed that area of triangle is equal to half base into altitude. So first we will find here area of triangle ADE. This is the first area which we will find here, and this is our triangle ADE. Applying the formula of half base into altitude here, for triangle ADE we can see that base is DE. So here we will write half DE into altitude, and corresponding altitude for base DE here is AM. So here we will write this as AM. Next we will find area triangle ABD. So let us find area triangle ABD. This is equal to 1 by 2. Now this is our triangle ABD, and for this triangle BD is the base. So writing BD here, this is multiplied by altitude, and for BD also the corresponding altitude will be AM only. So writing AM here. Next we will find area of triangle AEC. Now this is our triangle AEC. Once again applying the formula of half base into altitude. So 1 by 2 into base. Now the base here is EC. This is our base. So EC is our base, and this will be multiplied with the corresponding altitude. And for this triangle also the altitude will be AM. So this will be multiplied with AM. But it is given in the question that BD is equal to DE is equal to EC. This is given in the question, and when BD is equal to DE is equal to EC and AM is same, so that would mean that all these areas are equal. So this implies that area triangle ABD is equal to area triangle ADE is equal to area triangle AEC. So this implies from here that we can say finally that area ABD is equal to area ADE is equal to area AEC. So this is what we had to prove in the question. Let us do question number 4. In figure, ABCD is a parallelogram. So it is given in the question that ABCD here, this is our parallelogram, and BC is produced to a point Q such that AD is equal to CQ. So BC here is produced to point Q such that AD is equal to CQ. If AQ intersects DC at P, so AQ here is intersecting DC at point P, show that area BPC is equal to area DPQ. So this we have to show in this question, that area BPC, that means area of this triangle, is equal to area DPQ. That means area of this triangle here. So what we have to show in the question is that area BPC is equal to area DPQ. And the key point in this question will be triangles on the same base and between the same parallels are equal in area. So this is our key point. Triangles on the same base and between same parallels are equal in area. Now what we have to show in this question is that area BPC is equal to area DPQ, and our construction here is join AC. So for proving this question we have joint AC. This is our construction. Now let us prove this. Now it is given in the question that ABCD is a parallelogram, and when ABCD is a parallelogram, we know that opposite sides will be parallel. So AB is parallel to DC and AD is parallel to BC. And we know that this is so because opposite sides of a parallelogram are parallel to each other. Now consider triangles APC and BPC. So let us consider triangle APC here and triangle BPC here. So we are considering these two triangles, and in these two triangles we can see that these two triangles are lying on the same base PC. Base PC is same for both the triangles. Also we can see that these two triangles are between the same parallels because AB is parallel to PC. We have already said that AB is parallel to DC and PC is a part of DC only. That is why we can say that AB is parallel to PC also. Now we can visualize that triangle APC and triangle BPC, these two triangles are on the same base PC and between the same parallels AB and PC. That is why, as discussed in our key point, we can say that areas of triangle APC and BPC are equal. So here we can write that area triangle APC is equal to area triangle BPC, and this we can call as our first. Now let us consider quadrilateral ACQD. So this is our quadrilateral ACQD. This we will consider, and in this quadrilateral we can see that AD is equal to CQ. This is given in the question. And also, since AD is parallel to BC, as these are opposite sides of the parallelogram, and here we can see that CQ is an extension of BC only. So we can conclude from here that AD is parallel to CQ also. Now in quadrilateral ACQD, we can see that AD is equal to CQ. That means these two opposite sides are equal. Also, we have proved that AD is parallel to CQ. And we know that if in a quadrilateral at least one pair of opposite sides is equal and parallel, then our quadrilateral is a parallelogram. So in quadrilateral ACQD, we can see that AD is equal to CQ and AD is parallel to CQ. Therefore, we can see here that ACQD is a parallelogram. Now consider triangles AQC, this triangle here, and DQC. So we are considering these two triangles here, and we can see that these two triangles are lying on the same base QC and also are between the same parallels AD and QC. So once again, as discussed in our key point, if two triangles are lying on the same base as QC here and are between the same parallels, then the area of two triangles is equal. So here we can say that area of triangle AQC is equal to area of triangle DQC, and this we can call as our second. Now here, from our second, subtract area triangle PQC from both sides. So in our second, we are subtracting the area PQC from both sides. So this implies here that area of triangle AQC minus area triangle PQC is equal to area triangle DQC minus area triangle PQC. Now let us look at our figure. So from our figure, we can see that area triangle AQC, that means this triangle here, and from this triangle if we subtract PQC, so that means from this triangle here we are subtracting this triangle here, then we will get our triangle APC. So this implies here on our LHS we will have area triangle APC is equal to, and now let us look at the right hand side. In right hand side we have area triangle DQC, that means this triangle, and from this triangle if we subtract area PQC, that means this area here. Let us look at the right hand side. On the right hand side, if from area of triangle DQC, that means this triangle here, we subtract area triangle PQC, then we will get area DPQ. This will be obtained. So here we can write area triangle DPQ, and this we can call as our third. Now from first and third we can see area APC is equal to area DPQ, this is our third, and area APC is equal to area BPC, this is our first. So here we can see that in first and third, left hand sides are same. So this will imply that right hand sides are also equal. So this implies here that area triangle DPQ is equal to area triangle BPC. And this is what we had to prove in this question. This is our final answer. Area triangle DPQ is equal to area triangle BPC. So let us do question number 9. In question number 9, it is given that side AB of a parallelogram ABCD is produced to any point P. So it is given in the question that ABCD is a parallelogram. That means side AB is parallel to DC and AD is parallel to BC. And side AB is produced to point P here. A line through A and parallel to CP meets CB produced at Q. So we have a line through A which is parallel to CP and meets CB produced at Q. Then parallelogram PBQR is completed, and then we are completing the parallelogram PBQR. So if PBQR is a parallelogram, then this side here, that means BP is parallel to QR and BQ is parallel to PR. When all this is given, then we have to show that area ABCD is equal to area PBQR. So this is what we have to show, that area ABCD, that means area of this parallelogram here, is equal to area of parallelogram PBQR. So here we have to show that area of both these parallelograms are equal. Let us look at the key point for this question. Triangles on the same base and between the same parallels are equal in area. So if we have two triangles which are on the same base and between the same parallels, then the two triangles are equal in area, and diagonal of the parallelogram divides it into two triangles of equal areas. So a diagonal of a parallelogram will divide it into two triangles of equal areas. So let us solve the question. Area ABCD is equal to area PBQR. This we have to prove, and for proving this here we have a construction, join AC and PQ. So we have joint AC and PQ as our construction. In our key point, we have discussed that if we have two triangles on the same base and between the same parallels, then the two triangles are equal in area. So if we look at triangle ACQ here and triangle APQ, we can see here that these two triangles are on the same base AQ and between the same parallels CP and AQ. Therefore, areas of these two triangles are equal. So here we can write, so area triangle ACQ is equal to area of triangle APQ. Now here, from both sides, if we subtract area triangle ABQ, then we will get, so here we will have, this implies area triangle ACQ minus area triangle ABQ is equal to area triangle APQ minus area triangle ABQ. So we have subtracted area triangle ABQ from both sides. Now from our figure, if we look, then we can see that if from area triangle ACQ, that means from this triangle, area ABQ is subtracted, that means this area here, if subtracted from the complete triangle, then we will get area triangle ABC. So this is the remaining area after performing the subtraction. So here we will have area triangle ABC is equal to, once again referring to the figure, from triangle APQ, that means from this triangle here, if we subtract ABQ, that means if this area is subtracted from this area here, we will get QBP. This is our remaining area here. So that means area triangle ABC is equal to area of triangle QBP. And we can call this as our first. In our key point, we have already discussed that diagonal of a parallelogram divides it into two triangles of equal area. Now here we can see that AC is the diagonal of parallelogram ABCD. So it will divide the parallelogram into two triangles of equal area. So here we can say area triangle ABC, that means area of this triangle here. So area triangle ABC is equal to half the area of parallelogram ABCD. So this is equal to 1 by 2 area of parallelogram ABCD. This we can call as our second. Similarly, PQ here is the diagonal of parallelogram PBQR. So PQ is the diagonal of parallelogram PBQR here, and this diagonal will also divide the parallelogram into two triangles of equal area. So here we can say that area QBP, that means area of this triangle. So area triangle QBP is equal to 1 by 2 times area of parallelogram. This time we will have parallelogram PBQR. So we'll write parallelogram PBQR, and this we can call as our third. Now we have already proved that area triangle ABC is equal to area triangle QBP. So area triangle ABC is already equal to area triangle QBP. So in second and third, if LHS are equal, then automatically RHS also becomes equal. So from 1, 2 and 3, we can say that half area parallelogram ABCD is equal to half area parallelogram PBQR. So from 1, 2 and 3, we can write this implies that 1 by 2 area of parallelogram ABCD, so parallelogram ABCD is equal to 1 by 2 area of parallelogram PBQR. Now we can cancel the half on both sides. So this will imply from here that area parallelogram ABCD, this is equal to area parallelogram PBQR, and this implies from here that area ABCD, this is equal to area PBQR. And this is what we had to prove in this question. Area ABCD is equal to area PBQR.
Thank you for watching this video. For more videos, please subscribe our YouTube channel. Thank you.